So we're on to teaching strategies for solving problems. Generally, thinking about problem solving as situations where pupils don't have a kind of ready process that they can jump straight into to do what they need to do. So where they have to step back, make a judgment about the mathematical situation they're looking at and make their own decisions about how best to enter that. They have to approach it flexibly and work it out themselves. So we're going to look at one particular example. Before we go down, so yeah, we're going to look about solving a simpler but related problem, which comes under teach pupils to use and compare different strategies. I've talked a little bit about that. Using worked examples and self-explanation, actually Pete's going to talk a little bit about when he talks about metacognition. And then another message around that is the importance of considering and discussing problems both with similar structure and different contexts, and similar contexts for different structures. We're going to touch a little bit on that, but that came through as something that's really a good bet, and I think something kind of a missed opportunity. Who is primary? Just give me a wave if you're primary. Okay, loads of primary. And secondary, okay, oh, actually it's probably about half and half. Okay, so that's one thing I've definitely noticed in I'll just do a quick primary example, that's right for a second. The SATs questions over the last 2 years is seeing like similar structures coming up in year 6. SATs, really identical structures, but just with a different set of numbers. So last year, 2 years ago in SATs, there was a year 6 SATs question about cupcakes were 20 pence each, I think, or 25 pence each, and however many you bought, you got one bag for 15 pence, and it was around working out if you had 17 cupcakes in a bag, how much would that be, and if you spent £5 and 15 pence, how many cupcakes would you bought, and so on. And then last year there was a problem with exactly the same structure, which was about cooking chicken. So for every kilogram of chicken weighs, you have to cook it for 40 minutes plus 20 minutes for regardless of the weight. And so those two structures are exactly the same, and that's got me thinking quite a lot about actually maybe that we don't enough look at the same structure but with different contexts, and there's a good research evidence to say that's a good bet. So one of the things is that the structure of finding a missing angle in a triangle is exactly the same structure as buying yourself a pack of crisps and a drink and finding a change from £5. You've got your hole defined, your 180 degrees, and you know 2 of them, and you're finding the third, or you've got your £5 note and you're buying 2 things and finding the change. So that's a really good example of 2 questions that on the surface appear quite similar and quite different, and probably wouldn't normally be taught similarly in a similar time, but have exactly the same structure of the whole is defined in 2 of the parts, and you're finding the missing part by using those other 2. So we're going to talk a little bit about question that might challenge children. It's not in the primary curriculum, but probably if we are primary, we can see where children might be likely to go wrong. It's secondary. I have been told reliably that would be common answers. That would be 4. Is that right? Yeah, that would be pretty common, would it? Yeah. Okay, fine. So let's have a little look, just a really kind of simple chain of reasoning, going back to a similar example. So ties back to the misconception Pete talked about, well, division makes smaller, so it's going to be smaller than 12 is the answer. We'll also have a little look about the turnover and multiply rule, why that works. So we'll get on to that as well. So going back to a simpler example, so if we think about how many 5s in 35, or what do I multiply 5 by to get 35? There's not pictures on the lovely slides Jeremy did, but I have to draw it out. So we've got 35 as a whole. How many 5s? 4, excuse me, not equal. Okay, so how many 5s are in 35? Or another way of conceiving it, it's not on there, but another way of conceiving of it is what number are there 5 of in 35? So I guess in primary we call it like the grouping and sharing model. So what number are there 5 of in 35? Well, okay, so whichever way we look at it, we've got 7. There's 5 of 7 in 35, or we've got 7 groups of 5. So that's a question that's pretty accessible to most children. And if we just follow those same questions, then we can start to expose the structure for 12 divided by a third. So how many 5s in 35? How many 1/3s in 12? number is there 1/3 of in 12? So that's the other way of thinking about that. So I'll just kind of sketch out those two. I have to conceptually do it. So, sorry, I seem to have to click this about 10 times to get it to move on. Is either running out of batteries or am I pointing it completely in the wrong place? What I'm pointing it at, quite frankly. Sorry, right. Okay. So, yeah, I don't know what, I don't quite know where I'm meant to be pointing it. So if we kind of take those two models then, so now thinking, that's how we can conceive of that question, how many 1/3 are there in 12? So we've got our groups of 1/3 here, and we can see that in 12, we're going to have 36 of those 1/3. So that's one model. The other way of thinking it is, what number is there 1/3 of in 12? So that's a bit harder to conceive of. Okay, what number were there 5 of in 35? What number is there 1/3 of in 12? So there's our 12. What number is that 1/3 of? So that then gives us our 36 as well. So you've got those two different ways in which, from a primary point of view, come from what we call the grouping model and the sharing model, but can also be called, that's a measurement model and partitive model as well. So that gives the two different ways of conceiving of that, just starting from quite a simple question that children would be really comfortable with. And it's the second one there that you can see that then links to why 12 divided by 1/3 can be calculated by 12 times 3, it makes that linkage. So, we're going to kind of come back to this in a second, because we're going to think about the power of thinking about stories as a way to help children develop problem-solving strategies as well, and construct some sense of problems. So this is, I don't know if it's either directly from ICAMS or heavily drawing it is, or heavily drawing in ICAMS work. If you have most secondary schools used ICAMS in some way, just give me a wave if you've used ICAMS. Okay, if you've not, oh my gosh, the resources are amazing. I'd really recommend looking them up. And actually, there's resources straight off here on that. So, double C, it's something like increasing confidence and competence with multiplicative structures or something. I'm not sure about that. Algebraic multiplicative structures. The resources are absolutely amazing. Here's a story. We'll come back to our 12 divided by 3. 12 divided by 1/3 in a minute. So here's a story for 4 out of 10. The jar contains 4 red pens and 10 blue pens. How many pens is this all together? And then the prompt is to think of a story, another story for 4 out of 10, and think of a story for 4 times 10. So I'll just give you a quick chance to do that with the person next to you. Okay. Well, I maybe will just say something. Okay. So the message that Jeremy, who led the research review, was keen that we stress here, which has definitely been my experience, is initially children will be really, really bad at this. And it's not because intrinsically it's a particularly hard thing to do, it's just they have not been taught to do it and have not been given the experience of doing it. Out of interest, who does, in any way, as a regular part of their practice, do this, kind of look at a symbolic representation and ask children to give a real-world situation that corresponds to it? Yeah, so that's, even in this group, this probably is still a minority. Was your experience initially children struggle with it?
Yeah, initially.
Yeah.
And now they're getting more confident with it, and those children that are less confident generally still find it quite challenging.
Yeah.
But others are able to do it.
Yeah, my experience was when I started doing it, I was pretty horrified by the kind of stories I got. And they will initially, especially at primary, maybe at secondary, start with stories like, well, there was a man called 4 and a lady called 10, and they went for a walk and there were 14 of them or something like that. And then they get slightly more, I mean the multiplication ones are interesting. What I found when I started doing it, and having worked with lots of year 3, 4 teachers, and of course along, a typical multiplication story will be something like, Jake has 4 apples, Jack has 10 apples, times it, and altogether they have 40 apples. That would be pretty typical. And actually that's not that surprising, because certainly at Key Stage 2, everything they've met up till the start of Key Stage 2 tends to be about putting apples and apples together. And the idea that multiplication is a completely different structure. It's 4 lots of 10. You've got an operator and a quantity. It's 4 lots of 10 apples, not 4 apples, lots of 10 apples. So I'd really, the research says it's a good thing to do, and it's a really interesting and useful thing to do in the classroom from my point of view as well. So now you've had to think about 4 times 10 stories. Have a think. I think it's quite challenging initially. So can you now invent a story going back to that? 12 divided by 1/3 is 36. So we have now got our little models up. So I'm not anywhere going to nick 36. How many 1/3 in 12? There's a couple of models that might help you. So just have a little go at thinking about that. There's some up as well. Does anyone want to be brave and give a story for that? So it's probably not at all brave for secondary. You probably think we're complete idiots. It's totally obvious. But go on, give us a story.
Baker has 12 cakes and chops each cake into 3 pieces.
Yeah. So and so how many thirds of a cake they're going to have? Yeah. Go on.
By 12, so I was suffering this cake and
Yeah. So these are both this idea of dividing up into groups of 1/3. Well, any takers? Jeremy's kindly given us a couple. Are there any takers for that? I think that's quite challenging. Go on.
12 pupils represents 1/3 of my class. How many children are there in my class?
Yeah. That's a really nice example. I mean, lots of scaling up. I've done 1/3 of the job and I've done 12 of it. I've built 12 miles of road, and that's 1/3 of what I'm trying to build, that kind of thing. So that is interesting. That's in some ways a lot more challenging as a model, but that is the model that the kind of invert and multiply rule depends on. That the way of solving 12 divided by 1/3 by converting it to 12 multiplied by 3. That's the model that it draws on. Yes, am I right? Yes, I'm on the limits of my math there, but I've enjoyed thinking it through. Okay, so here's some here. What I will challenge you to do is think about whether it's using this kind of measurement model up here or this model down here. So have a think about that. How many 1/3 litres of glasses, 1/3 litre glasses can I bought from 12 litres of juice? Top model or bottom model? Top model or bottom model? Top, yeah, brilliant. Okay. One side of a rectangle is 1/3 centimetre long. If its area is 12 square centimetres, what's the length of the other side? Yeah? Got that one's a model as a model. That's not clearly there's getting into area model there. But you've got your 1/3 by 36. A scale model of a building is 1/3 of life size. And if the model is 12 metres tall, how tall is the real thing? Yeah, that one is bottom. Yeah, can you see that's more the bottom model there? And then one more. I travel 12 miles in 1/3 of an hour. What's my average speed? Yeah. So quite kind of challenging structurally to think of, but leading in quite nicely from really quite simple division facts that children will have been learning all the way through Key Stage 2 and beyond.